All right, now you guys know the real reason why I do these events is just so I can give talks. I haven't given a talk in a while, so hopefully this works well. I made this while I was sitting back there. I didn't have slides, but I did have the code done earlier today. So I had the code done at like 3:45, and I built the slides just now. So I hope this is all going to go well. But who has built a RAG app before? Let's see a show of hands again. A few of you. Can you guys raise your hands a little bit higher? Just be proud of yourself, right? Like, come on. This is like the cutting edge of technology, guys. What about an AI agent? Okay, and a lot more of you have built AI agents than RAG apps. That's actually crazy to see. What about a RAG agent? What's the difference? Great question. A RAG agent is a type of agent, but it is also a RAG app. But unlike traditional, actually, you know what? I'll explain it right now. So unlike a traditional RAG application where you tell like the application what to look for and which vector database to search, the agent will decide which vector database to search based on the query that you give it, okay? So we're gonna see that in action. Yeah. All right. Okay, so I'm gonna give you guys this demo code on how to build a RAG agent. We're gonna be doing, I should have just used this slide when you asked that question. You know, anyway, yes, we're gonna be doing RAG with autonomous agent execution. So later today we'll be seeing a demo from someone who does human-in-the-loop agents, but this is about autonomous agents. This QR code will take you to a GitHub with a link to the notebook that contains the code. So if you would like to follow along on your phone, which I understand is quite difficult to code on your phone, but if you would like to follow along on your phone, you can scan this QR code, and you can see the link, and you'll see the, well, I hope this is the right link. Let's make sure. Okay, so you'll have to go to this, I should have just given the full link, but once you get to this repo, you'll go to Llama Index, you click Llama Index, and you'll click OpenAI RAG agent with evals, okay? So Llama Index, OpenAI RAG agent with evals. All right, everyone who wants the QR code has the QR code, okay? The rest of you, you'll see the code on the screen anyway. So for this, we're using Llama Index, GPT-4, Face, and Arise Phoenix. So who's built something with Llama Index? Who's familiar with this library? A few of you? What about LangChain? Is everybody more familiar with LangChain? No. Okay, so neither libraries. You guys don't like either of these libraries. What about Face? Does anyone know about Face? Face? Okay, cool. What about Arise Phoenix? Does anyone know about Arise Phoenix? One of you? I work with them a lot, so I really like their open source library. GPT-4. Who's familiar with GPT-4? Great. Most of you familiar with GPT-4. Okay. So that's basically what we're doing. This is the architecture. It's very, very simple. This is like a toy application. But the goal of this is to just walk you through how it works. And you know, after this, you'll be able to play around with it, and you'll be able to do whatever you would like with it. But in this example, we are really just playing with a very, very small RAG agent, okay? This is like totally like toy application. You're never going to build anything like this in production. And if you do, it is totally overkill. But the way it works is you have this big box that is just the agent itself. And the agent itself, in this case, is going to be an LLM. And I'm making two vector databases. Okay, you can use 1, you can use 3, you can use 5, you can use 2, you can use whatever. You can use tools other than vector databases, but in a RAG application, you pretty much just need a vector database. So we're going to be making two vector databases, and we're going to be basically soft linking them to the LLM by providing them as a tool, okay? So the core functionality of an AI agent is that they use LLMs to achieve goals using tools and workflows that the LLM comes up with itself. So in a traditional RAG application, like we were talking about earlier, you define the RAG workflow. In an agentic application, you simply define the tools, how to use them, and the goals involved. And then the LLM will, not always autonomously, but the LLM will execute we'll decide which steps to execute, and then execute some steps and use those functions to achieve a goal that you give the LLM, okay? So, any questions here before we dive into the code? All right, you guys all ready? Everyone wants to see the code. This is not the right code. This is the right code, okay. All right, so I'm using Python 3.12. You can also use Python 3.11. I don't think it works with Python 3.13. That seems to be like, I don't know, like whenever you upgrade to the latest Python, all the libraries break. Whenever you update the libraries, they all break. So anyway, we're just going to be, this is, by the way, this UV stuff, it doesn't matter unless you're using GitHub Codespaces. Shout out to GitHub. Anyway, I'm going to install these libraries, right? So I'm going to install a specific version of Llama Index because I know this version works, right? So versioning is very important in Python. Who here is a Python developer? Okay, who here has run into versioning conflicts in the last month? That should be all of you. Okay, so I use a specific version of Llama Index. This is the latest version, and this happens to work fine, but maybe I should also use a specific version for this. This also works fine. This is the embeddings for OpenAI. So embeddings are, they create vectors. Vectors are long series of numbers. Embeddings, vectors, these are interchangeable terms. If you hear someone say embeddings, if you hear someone say vectors, vector embeddings, all the same thing. Okay, and then, this is actually an out-of-date installation. I installed this for the last one. Anyway, we'll also use Open Inference Instrumentation for Llama Index and Arise Phoenix. And this is just for environment variable management, right? So you want to write nice, clean code. You want to use a .env file. You don't want to expose your environment variables, your API keys to the world. So yeah. Okay, that's all you need. Just a few libraries, like I said, totally toy library. Oh, and face CPU should be here somewhere as well. It's not, whatever. So all we're doing here is we're just going to set up our API keys, okay? So if you use OpenAI, you're probably familiar with this. All we're going to do, load up our environment variables, assign the environment variable to the right variable, the global variable, in this case, OpenAI API key. Okay, now I'm going to import some libraries. I'm going to set up Llama Index. So let's run this. All right, who's done a live code demo in the last month? One of you, okay. Well, we'll have some fun, and we'll hope that this live code demo works. Okay, so what I'm going to do here is I'm just going to import a bunch of libraries, right? So from Llama Index, I'm going to import these 4 libraries. They're pretty self-explanatory. Simple directory reader, that reads a directory. Vector store index creates a vector store index. Storage context is a way that you pass context and storage. I've actually been told that they're going to update this and make it slightly different, but this is what it is in this versioning. And then load index from storage. This one you won't need the first time you run it, but if you like to rerun a lot of your code and save indexings, which you should because it takes a long time to embed and then store and then create an index, so you should try to save your indexes as long as you're not updating your data too much. This basically does that. And then we're going to get the query engine tool and the tool metadata tool. So query engine tools, query engines, basically what they do is they allow you to take plain text and query for plain text. So it's like a vector database, but without having to turn something into a vector first, you just give it the text and it turns it into the vector for you. And there's tool metadata. What this does is this gives you the metadata for how to use the tool. There's a React agent. Who's heard of React agents? Have you guys heard of React agents? Reasoning action agents. Okay, React, not like the language React. That's what this is. And then this is OpenAI, and we'll get GPT-4. And everything has run in 2.1 seconds, so nothing is broken yet. Okay, so the next thing I'm going to do is I'm going to set up Phoenix. So essentially what this will allow me to do is this will allow me to look inside of my workflows. So it looks something like this. I need some water. All right, sorry about that. Okay, here what we're doing is we're importing some packages, and we're just registering this trace for Llama Index. OpenTelemetry, I assume everyone's familiar with OpenTelemetry. This has been around for a long time. Everybody knows what OpenTelemetry is? Yes? Okay, a lot of you do. Blah, blah, blah. Okay, so now what I'm going to do is I'm going to load the documents, right? So the first thing that you need to do with any RAG application is you need to load your documents into a vector database. So all I'm doing here is I'm saying, okay, what I'm going to do is I'm going to get this, what is it called? Directory. I'm going to persist it into this directory. And if it's already there, I'm going to just load this directly from the directory, right? So that's what the load index from storage is. If you haven't loaded the index, what you're going to do is this is what will run the first time you do this. You will run the directory reader so that you can read in the directory of files, and then you can load that data into a vector store index, right? So you take your files, you vectorize them, and you put them into an index, you name the index, and then in this one up here, you can see that I've loaded these indexes from the ones that we save it into here. Oh, thank you very much. This is great. If I had a prize, I would give you a prize, but I don't have any prizes. I used to throw socks at my talks, but I don't have a sock right now. So, okay. So yeah, vector store index here. Basically, you load them into vector store index, and then you persist them into these directories, which is what I'm loading up here when I call my storage context. Okay, and now what we're going to do is we're going to create the query engines. You can see the English here as well. Basically, what this does is this creates a way to query. Oh, okay. I only have space for 2 drinks up here, unless someone wants to bring me a beer. So what this does here is this allows us to. I lost my train of thought now. To turn the index, the vector index, into a query engine, right? So vector indexes, what they are is they're a way to compare text, right? You turn text into vectors, which are numbers, and now you have a quantifiable way to compare them, and that's what a vector index is. And now we've turned this, and we've turned it into a query engine, which means that instead of querying with vectors, we're going to query with text, and we're going to say we want the top 3 results, and we're going to pass the LLM that we're going to use to query these, to give these query engines, okay? And we do that with Lyft and Uber. Oh, I totally forgot to tell you guys the data. The data that we're looking at for this one, this is very important, by the way. Data is probably the most important part of your AI application, is the Lyft and Uber 10K forms from 2021, okay? So that's what we're looking at. And these are PDF files, so I'm honestly surprised that it works this well. Okay, so now what we're doing is we're creating query engine tools. So the query engine does the querying. Now the agent, the LLM, needs to be able to perform that query. It needs to be able to use those tools, right? So agents, the primary thing that they do is tool usage. So what we're doing here is we're creating tools that the agent can use. We're giving it a name, Lyft 10K. This is the 10K for Lyft. And we're giving a description. So this provides information about Lyft's financials for the year 2021. And the way you use it is you use a detailed plain text question as input into the tool. Okay? So now our LLM can query these tools autonomously. It can decide, it knows what the tool will do, and it knows how to use the tool. Okay, so there's 2 of these, right? So now we have 2 vector databases, 2 query engines as shown. And now we're going to create the agent. So this is a React agent. This is saying we're going to create a reasoning action agent, and we're going to give it these tools. We're going to give it the query engine tools we just showed above, and then we're going to have an LLM, and we're going to say, hey, let's make this a verbose LLM, so which means it will show us the thoughts, the train of thought, right? Who's heard of train of thought, chain of thought, right? This is one way that you can get your LLM to think better. And we're going to give it a max turn of 10, so we don't run into any recursion where we're going to be having the LLM run for like let's say 20, 50, whatever, and it's going to cost us a lot of money. Okay, now, the most exciting part is we're going to ask the agent some questions. So this is a question that I have loaded up. Who had more profit in 2021, Lyft or Uber? All right, before I ask the LLM, let me ask you guys what you think. Okay, if you think it was Lyft, raise your hand. If you think it was Uber, raise your hand. Okay, so a lot of you guys think Uber made more money than Lyft in 2021. Are you willing to bet on it? No, I'm kidding. Okay, so we're going to ask the LLM, and it's going to check the 10K, and it's going to tell us what actually happens. Assuming that everything works as according to plan. So it says, thought. The current language of the user is English. That is the only language I speak. I need to use the Lyft 10K and Uber 10K tools to help me answer this question. So we're going to use the Lyft 10K. What was Lyft's profits in the year 2021? Notice that I did not ask it what this was. It came up with the question itself, and then it went and queried it, right? That's the agentic piece of the application. And then it says, Lyft's reported a net loss of, that's a lot of money in 2021. And then, here we go, Lyft reported a net loss. I need to find Uber's profit. Uber reported a net loss of a little bit less money. So neither Lyft nor Uber made a profit in 2021. However, Uber had a smaller net loss of $496 million compared to Lyft's $1.09 billion, making it relatively more profitable. Okay, so we have a few minutes left. Does anyone want to ask me or the LLM any questions? Oh, this guy here, Cody.
All right, had to go to my microphone stash.
Hi, thank you for the intro. I'm wondering what would you do in cases where you have a lot of databases and basically you cannot define each query engine in each database, what
happens if you have a lot of databases, you can't define a query engine for each database?
Yes, like you have so many that it's not feasible to write a query engine for each one of them.
Yeah, in that case, what I would suggest you do is you put everything into all your documents. So in this case, I'm putting each document into a vector database. That's bad practice. You should put all of your related documents into the same database. Now, is there a specific use case that you have in mind where you may have too many databases?
I'm thinking like where you want to make a generic agent and you might have like multiple data sources that they're not all the same, they don't come from the same distribution. So they could have different meanings, not the same. You can have legal document, financial document, so many different types of document. And you want to build an agent that can cover all these types of questions.
If you want to build an agent that's going to be able to cover all those types of questions, what I would suggest that you do is actually just build multiple agents.
Okay, thanks.
Yeah.
Any other questions?
Looks like that guy back there. You want to shout the question out loud? I'll repeat it.
So, RAG is one of the approaches to fetch, let's say, new fresh data from databases and context. Well, another approach is also just to put it in context, especially with long context, Gemini, tokens. What do you think is going to be the future of RAG? Do you think RAG has an application? Long context has a better application?
All right, so for those of you who didn't hear, the question is, RAG is one way to put information into context, but another way is to just put the context directly into the context of the LLM. So, and then do I think RAG has a future? So you're asking the right person, because I used to work at a vector database company and I have a canned response for this. But I also have an actual response for you. So my real thoughts on this are, who in the world is going to go and put all of that specific information into the context of a long context LLM every single time? That costs so much money and it takes so much effort. I would not have that patience. I doubt any of your developers will have that patience. So I think that RAG has a place due to that. The canned response is, RAG is cheaper. But that's also a real thing.
There's also context caching. That's why it's...
CAG. Is that what you're talking about?
Yeah.
Context, yes. That's available if you have enough RAM in your GPU to cache all of your responses. But also, that has the downside. By the way, that's totally a feasible option. But that means that you can only have relevant data from data that's already been run through by the program. And so this is an interesting point. So AMD has more GPU RAM than NVIDIA. And right now, pretty much everything runs on NVIDIA. So I don't think this is going to be feasible until more and more things switch to AMD. Is it going to be a feasible solution? I think this will be a piece of a larger solution, just like I think RAG will be a piece of a larger solution. It won't be like, oh, like this is the end-all, be-all of context retrieval, information retrieval, right?
Yeah, no, it's good. Yeah, it's just optimizing RAG is a really tricky problem.
It is indeed. And I no longer work at a vector database company, so I have nothing to say about it.
Okay.
Was there another question over here? That was you.
Is there a recommended algorithm for chunking the PDFs that you'd use?
Ooh, you have asked a very good question, sir. I have a whole course on this on LinkedIn called Advanced RAG with Vector Databases. I would suggest that you go take the course.
Is it paid? Is it paid?
It's on LinkedIn Learning, so if you have a premium course, it's free, but if you don't, I think you just have to buy a LinkedIn Premium subscription. You know how Microsoft... Yes, the answer is yes. You get free access to LinkedIn Education. With what? With the public library.
With San
Great,
Francisco
there you
Public
go,
Library?
the public library.
All right.
I love
Excellent.
that. They're giving out free educational resources. I'm all about it.
All right. Do we have any more questions over here? All right. We're way down there. But while I'm on way, oh, go for it.
Great question. And let me, so the question is, why would you have two vector databases? And if you have two vector databases, does it bias the LLM? So let me address the first question. You see here, up here, we define a number of top K. So if I want to have more context, I can do that by having multiple query engines. Now, I could put these into the same query engine, and to be honest, I'd probably get the right answer. But this is, once again, the example here is if you want to have that context from both sides, an equivalent amount of context, that's when you would use something like this. Would it bias the LLM? I don't really know how to answer that, so I'm going to say I don't know.
Hello? Yeah.
Hello.
Sorry. Yeah, let's have some more fun with the agent. Probably
Okay.
like ask the question like, this time, let's ask a question where it would need only one tool, maybe either Uber or Lyft, and let's see if it would still leverage both the tools or just one tool. That's probably one scenario. And second, maybe we
Give me the question. Give me the question. What's the question we want to ask the LLM?
Yeah, what was the profit for just Uber? Let's remove Lyft.
Let's find out. How smart is this agent really? Pretty smart.
Probably let's do it this way. Like, I am a fan of Lyft, but what do you think of Uber's profit? Something like that. So,
It's trying to trick the LLM. All right, let's see. This is a great way for red teaming, by the way. You give it the wrong, oh, I don't have any personal opinions. However, Uber reported net loss. The company has been investing heavily in growth and expansion. This could potentially lead to profitability. Many tech companies operate at a loss in their early years, blah, 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 blah. So it doesn't use the tool, but it apparently takes into account your being a fan of Lyft.
yeah. Yeah, cool. Somebody had a question.
Hey, great presentation. Love the live demo here. The diagram you showed in the beginning, that was actually very high level. Can you go a little bit deeper? What's happening? What are you doing with the vector databases? How the similarity search is working, and how you're leveraging in the LLM, and how is LLM calling these vector databases
Okay.
as opposed to other way around?
Okay, so you want to go a little bit deeper on this. I'll try to go fast. I only have 5 minutes left. Okay, so. All right, so what's actually happening here, right? The query goes to the LLM. The LLM is now an agent, has some thoughts. It says it has some reasoning, and it says, okay, I want to know about Uber. I want to know about Lyft. If I want to know about Uber, I'm going to leverage, let's just call this one Uber and this one Lyft. I'm going to leverage the query engine that tells me about Uber. So actually, there's another wrapper around the vector database that's a query engine. And then it says, okay, I know I need to query for profits from Uber. So what do? I send this query here, and I say Uber profits or something like that. And now the query engine takes Uber profits, it embeds it with the OpenAI embedding, and then it searches the vector database, which contains the embedded information, the information transformed into vector embeddings, and it says, find me the similar thing. And then it goes and it finds the top 3 results in that vector database. I'm not sure exactly how these vector DBs are set up. I just use the defaults. But you can change different things in vector DB, like you can change like top K, the similarity type, the way that you, I forgot, there's other things. Anyway, it basically says, I'm going to do that. I'm going to look for the vector embedding most similar to Uber profits, and then I'm going to return that information, all of that context. So it grabs the top 3 most similar chunks, it returns that context to the LLM, and then the LLM does the same thing with Lyft. It gets that context, and now it has context to answer the question, and then it formulates an answer, and it gives it back to you.
All right, who else?
What if you ask it like an irrelevant question?
Go ahead.
What was the weather on December 20th, 2021?
What was the weather in
In
SF.
San Francisco, sure.
on September 20, 2021?
Looks good.
I'm sorry, but I don't have the ability to provide past weather data.
Excellent. Yeah, I guess, is it re-ranking after the vector database search goes on?
It is not doing a re-ranking. That is something you have to manually implement with vector databases.
Okay, cool. Thanks.
Can you go in a little bit about your evals, especially for agentic RAG?
Great, let's look at the evals. So, here's what the evals look like. Let's look at the first eval. This one took the longest. Who had more profit in 2021, Lyft or Uber? So this is a trace, by the way. This is not the eval. So actually, if I want to add evals, I named the notebook wrong. If I want to add evals, there's these things called QA, hallucination, and relevance evals that Arise provides out of the box. It's like built into Phoenix. You can also define your own evals. I don't have that on here. We'll talk after. I can show you how to do that. But basically what this does is this says, okay, here's what's going on in each step, right? Here's the chat step, who had more profit. This is the final step, right? Here's the output for this specific step. This is what it looks like inside of the agent, right? These are what it looks like inside the agent. I'm running the task here, okay? This is another run step. I'm basically like saying, okay, what's going on here? Here's the observation that we have, net loss, Lyft reported net loss, and then there should be one that does this for Uber as well. And this is the context data, right? Lyft Inc. consolidated statements of operations, blah, 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 blah. And despite that this is like crazy text that you or I probably can't read very well, the LLM is able to parse this very well. So it shows you all of the context that it's grabbing. We have strengthened our business over the last year and confident in our abilities to continue to navigate this challenging period, blah, 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 blah. And then it does the same thing here for Uber, presumably. I hope this is Uber. Okay, well, I can't control F this. This is still Lyft, so I'm in the wrong one. Maybe this one's Uber. There's an Uber one somewhere here. Okay, obviously I can't find the Uber one, but it did look at both as it showed the output. But this is kind of what it looks like behind the scenes. You have these tools. Oh, see, okay, it knows that it's using Uber. Here's the output format, et cetera, et cetera, et cetera. Okay, I'm out of time. So,
All right, thanks, Yujian. Give it up for Yujian one last time.